beams on the actual cells in the eye that we use for colour vision.
This brings out then this business of the fact that we don't merely see with our eyes, but we see with our brains. Colours as such don't exist in the external world. There are only different wavelengths of light. And there is no simple translation of wavelength into colour. How wavelength becomes colour has fascinated generations of scientists, including the maker of the first colour photograph, the 19th century physicist James Clerk Maxwell. Here we are doing a reproduction of Maxwell's famous experiment here in 1861 when he photographed a coloured bow on black and white film through filters of red, blue and green, and then projected the images through the same filters and superimposed them and produced the first colour photograph. Here, instead of a bow, we're using 3 T-shirts, the red, green and blue T-shirts which I wore on Pingelab. We took 3 black and white photographs of me through red, green and violet filters. Positives were made from these photographs, and this morning these are being projected through filters of the same colour. And when we register these precisely, if it works, and I think it will, we will suddenly get recreation of the full colour of the scene. Maxwell was interested by Thomas Young's 3-colour theory. There were 3 tuned receptors in the retina, and that these would decompose the light, and that it could be reconstituted somehow in the brain. Maxwell showed that one could at least make a photographic or optical synthesis of a scene using these 3 primary colours. Whether or not this is a sufficient analogy to what happens in the human eye and nervous system was open to question. Since then, the search to understand colour vision has moved deeper and deeper within the brain. One question that has puzzled scientists has been whether there is a specific region of the brain dedicated to colour vision. Here, as we lift up the cerebellum, we see the association cortex, which has the areas necessary for seeing colour, seeing movement, seeing depth, recognizing form, and generally making sense of the visual world. It is here, in the small areas, sometimes called V4, that colour experience begins to take shape. One of the most exciting things for me was seeing the sudden appearance of colour. Suddenly, that was so exciting. It was almost like an orgasm. And it's similar in my mind to the sudden appearance of depth with a stereoscope, or the sudden appearance of motion with a film projector. And all of these things for me were like metaphors of mental acts. One suddenly saw the complex procedure by which you got to a new order of being. If colour experience is something that we individually construct in our brains, then how can we be certain that each of us sees the same colour in the same way? In the Royal Institution's laboratory, I was reminded of an experience of colour I once had that was so extraordinary that I've searched ever since to recover it. I had been tantalised by the idea that you might experience a colour you had never seen. Indigo. I was a bit of a druggie 30 years ago, and when I was very stoned, I said to myself, I want to see indigo. And as if flung by a paintbrush, a trembling, pear-shaped blob of shining indigo appeared, and I leant towards it in a sort of ecstasy. It seemed to me the colour of heaven, and then it vanished. When I found the bottle, I thought, this is it, eureka. But it's a rather dull colour, not like the radiant, mystical colour which I saw when I was stoned. I got a great sense of loss, and I kept turning things over and looking for it. I spent really 2 years in a fretful way looking for this colour. I did experience it once more when, undrugged, I was in a concert in the Metropolitan Museum of Art in New York in the Egyptology galleries. And in the first part of the concert, where there was some Monteverdi Vespers, I was enraptured. I felt a river of music, 4 centuries long, sort of flowing into me. And in this elevated mood, I went out into the galleries, and there I saw some lapis lazuli snuff boxes, and some of them had indigo. And I thought, it's okay, it's really there in the outside world, this beatific colour. In the second half of the concert, this sort of melting, magical feeling which had gone with the Monteverdi disappeared, and I felt a bit rather down, a bit bored. But I thought, it doesn't matter. I'll be able to go out afterwards and go back and see it. The indigo is still there. It's real. It's waiting for me. And I went out and I came back to the case, and it wasn't there. It wasn't there. There were blues and violets and azures and purples, but there was no indigo at all. There was none of that extraordinary, miraculous, mystical quality. There was none of the transformation which had occurred before. And there's a tremendous sense of loss and sort of fear and a sort of perplexity as well. And I felt something very precious had vanished, and I wondered if I would ever see it again. And I never have. The fact that a visual world and visual perception depends on the brain, I think, was forced on me very early, because I had visual migraines, as my mother had and as other people have. And in a visual migraine, there can be all sorts of changes. Sometimes there is just a brilliant scintillating spot, a zigzag, which gets larger and larger. But sometimes you can lose part of the visual field, half the visual field. Sometimes contours can change. Sometimes colors can change, get distorted, get attenuated, vanish altogether. I sometimes had this, even as a child. When 50 years later, Isaacson, the colorblind painter, told me of his total loss of color vision, obviously following brain damage and damage in the visual cortex, I was able to resonate to this, I think, the more so because I'd known such a thing, although rather briefly, in my own migraines. Isaacson, or Jonathan I, as I call him, was an abstract expressionist with a very vivid sense of colour, who, following a car accident, suddenly lost all colour perception. Knut has perfect neurological processing of the signals coming from his eye. He only has some of the signals, but what he does have, he processes perfectly and makes a world with. Now, with Jonathan I, on the other hand, although all the signals came from the eye, something went wrong in their cerebral processing, so that he couldn't construct colour. I think also that he couldn't construct a full grayscale.